All right, guys, I apologize. I don't have my green screen again, and so I'm probably a big white blob down in the corner. I should probably just turn off the camera so you don't have to look. This is part 2 on transformations, and so I have a little review slide here we can go real quick. Again, the order of operations would say we would start way inside here. So if you were looking at all these different letters or numbers being applied to a function, you would start in here, and the first thing you would do is do h. And remember, anything in the parentheses is the opposite of what it seems. So a -2 would actually go to the right, a +2 would go to the left. That's horizontal shifts left and right. The next thing you would apply is out here, the b. And because it's still in the parentheses, it is the opposite of what it seems, but it is affecting the x values, so it is a horizontal stretch or shrink. So it would change the x-intercepts. It would shrink the graph if it was a whole number like 2 or 3 or even 2.5. It would shrink the graph in towards the y-axis, okay? The x-intercepts would change. If it were a fraction like 1/3 in there at b, it would stretch the graph and the x-intercepts would change out away from the y-intercept. It stays attached to the y-intercept where it was. The negative inside reflects the graph across the y-axis, so it takes the left side and flips it to the right, and the right flips to the left. Then the next thing you would talk about is the A out here, and that would be horizontal, and that is not the opposite of what it seems. Did I say horizontal? Why does it say horizontal up there? Yeah, that's not a good... This is a vertical stretch or compression. If it's greater than 1, it's a vertical stretch. Let me see if I can fix that with my little tablet here. And if it's less than 1, it's a vertical compression. So that's just a mistake right there. All right, and that is changing y values. So it's stretching it up and down. It would not change the x-intercepts, but it would change the y-intercept possibly. A negative out front is reflecting over the x-axis, so it flips the top to the bottom and the bottom to the top. And the very last thing, according to the order of operations, would be way back here. You would shift the whole thing up or down. And remember, because this is not in the parenthesis, a +5 would go up 5 and a -5 would go down 5. All right, so today we are supposed to write an equation for this graph. It says the parent function is the light gray one. What is the transformed function? And what has happened here, it's the same size, but it has shifted the vertex over to here. When I say the same size, it might look a little bit wider, but if you look here, it was 2 units across right there, and it's still 2 units across just above the vertex. So it hasn't stretched. It has just shifted right 3 and down 1, which, because it's a parent function of x squared, we're going to write something squared. Now, right 3, remember, is the opposite sign, so it's minus, and down 1 is minus on the back. All right, number 16, the parent function is gray again, and it is the square root function. This has only been shifted left 1 and up 2. See how it goes up 1 and over 1 to get to that next dot? It's still doing that, so it hasn't been stretched. By the way, that's not a slope, okay, because it's not straight and linear, but it still went that amount, okay? So we went left 1 and up 2. Left 1, up 2. would be +1 in here and a +2 on the back, because anything inside is the opposite of what it seems. All right, so this one went through these 3 spots. If we go over here and we highlight those 3 dots, this either reflected upside down or across the Y. We can't really tell, and it really doesn't matter because a negative x to the 5th is the same as the opposite of x to the 5th. So which way it reflected doesn't really matter, but we have to have it reflecting once. And the second thing that happened is this dot that was its inflection point went 3 to the left and up 2. So it was reflected, we could say upside down. It could have been X or Y because the symmetry here is the same. It had origin symmetry. So if this is the original one, guys, if I reflect it upside down, it looks like this. Or if I reflect it left to right, it's the same graph. All right, so finishing this up, we have reflected left 3 would be plus inside here. It is still to the 5th power, that's the parent function, and up 2. And you could type this in your calculator. I don't have mine started. I'll just pull it up here in a second, and then we can type it in and look to see. It's going to be a little hard to tell unless you set your window exactly what theirs is. So I think I'm just going to minimize that, and we'll look at it in a little bit. All right. Absolute value. I love this, but I didn't assign much on this. It's really a fun idea. When you take any function and you put an absolute value around the f of x, it is taking all the y values and making them positive. So all these places that it was down here, it now makes them up here. So the absolute value of f of x has only positive values above the x-axis. It could also be shifted then, which would change that, but all right, this one is even more interesting. When you put the absolute value inside on the x, what it does is it makes all the x's that you had that were positive, okay, they stay where they were, but all the negative x's get put in as though they were positive, so you end up with a graph that has y-axis symmetry. It says the portion to the left of the y-axis is replaced by a reflection to the portion to the right of the y-axis. Someday maybe we'll do a matching activity during a Google Meet where we can try to identify some of those absolute value ones, but it is not one that I put on any of the questions we did today. So I have an example here, though, just to practice one more time. X cubed looks like this. The +1 would move it up 1, like this. And so it started out with an x cubed, and then we made it an x plus 1 cubed. I'm just kidding. Guess what? Doesn't move it up 1. Why did you not catch my mistake for me, guys? That's why I hate recording that are not live, because no one catches my mistake. Until you bring the computer up and say, I was watching this video and you messed up. Hopefully I catch it eventually. This actually moved it left 1. So it should have been crossing over here at -1. Okay. And then the absolute value is on the whole function. So it takes all the pieces that used to be down here and breaks them off and reflects them up here. So my prediction is it's going to cross here, and then it's this piece is still going this way. Let's see, 2 should be all the way up at 8, because 2 cubed is 8. And I went 2 over, which is the very top. It's very steep. All right. But then I'm thinking the piece that used to be doing this and going way down here is now going up all the way up here. So my prediction is that it looks like a very skinny parabola. So let's try this one on the calculator, just because we haven't talked about this absolute value symbol business very much. All right, so if I went to y equals, oh, I need to go up and turn this plot off. So I'm going to hit clear, just kidding. Y equals, up arrow, enter to turn that off, and clear. Can't have those black boxes on around the top plots, or it could mess up your graph. Not always, but most of the time it will. All right, I need absolute value of x plus 1 cubed. Absolute value is under math, and arrow to the right once. It is ABS, absolute value. I believe there's also a shortcut up here maybe. Yeah, if you go alpha window, it's choice 1 brings up the absolute value. The other shortcut I know that I learned, this is the only way I knew how to do it years ago, was second window, and absolute value is the very first thing. This is the catalog is under 0, and it's an alphabetical listing of every function on your calculator, and absolute value is the first one. All right, so somehow you get those absolute values. If you have an older calculator, it'll literally say ABS parenthesis, but this newer calculator brings it up. And then it says I need parenthesis x plus 1 quantity to the third. All right, and then I'm just going to do a zoom 6 for a standard window. And I think I was right. It's crossing down here at -1, crossing at 1, 1. If I put in a positive 1, so I went out 2, I'm going to go trace 1. I think it's all the way up at 8. Okay. So that was an example of the absolute value function, not on a quiz. All right, consider the logarithmic parent function. Okay, we are going to spend a whole chapter on logs, but for now, all it wants you to do is take this parent function and shift it up 2, which would become plus 2 on the back, and 3 units to the right means inside of the function here, I need to go right, which is a -3. So there's the equation for that one. Number 20 says consider the even power function x to the 6th, which just means it looks like this. Looks like a parabola shape. Write a transform function with the following characteristics. It opens down. That would be reflect over x. So we would have a -x to the 6th, is stretched vertically. Okay, now that means we need to put an a out in the front that's greater than 1. So we could put a 2, or a 3, or a 7, or a 1.8, anything greater than 1. So this is an open response question. Open-ended, you can have different responses, okay? Turns in the third quadrant of your graph. So the turn it's doing right now is at 0, 0. This was original. We flipped it upside down and stretched it, okay? And it actually looked narrower because it went up faster. But they want this point that was at 0, 0 to move over here somewhere into the third quadrant. Remember, the quadrants go 1, 2, 3, 4. So I need to shift it left and down. So I'm going to go left would be plus, and down would be minus. Now, that is not the only solution. I just put some numbers in there, and this was supposed to be a 6. All right, so let's see if it meets all those requirements on the calculator. y equals clear -2 parenthesis x, I forget what I wrote, plus 3 to the 6th, arrow to the right, minus 5. I'm going to leave my standard window. Okay, just to show you, it was an x to the 6th, which is actually very interesting. What it does is it's a parabola, but it's really flat at the bottom because it stayed there very close for quite a while because of the 6th power. So this is the original. We shifted it left, reflected it upside down, we shifted it down into the 3rd quadrant. It's very hard to tell that we stretched it. Let me put a number out here like 9, and it should look narrower. There we go, because it's stretched vertically. Okay, so I could change that 2 to a 9 if we want. All right, running through these quickly, these are using the same thing. What is the parent function? It's not given because I wanted you to identify. This is an absolute value. So there's the parent function, okay? You might need to use your notes. Now to translate to the right, I say minus. And then this is separate, guys. For part C, it doesn't have to do with B, I don't think. We're just going to do a whole separate problem. So we're going to go this one, reflected over the x-axis would be a negative up front. And then up 5 would be this. If we had done it to this, it would be the same. We'd put the negative and then the plus 5 on the back. But I'm doing part C as a separate problem. All right, I'm going to skip this one, come back and do it on the notes, but we don't do this parent function very often. This is the parent. All right, this is a greatest integer function. And Ms. Gupta says you have to know this one for calc. Not my favorite to try to graph because I get confused which stretch does longer sticks and which one does higher. And luckily we can kind of use the calculator, but translate up 1 unit. Well, this is just our general function, up on the back 1 unit. And vertically stretched by a factor of 4 is applied to the x. Now I'm just curious what that does. If we go back here, the greatest integer function is under math, arrow to the right again, it's integer, choice 5. So this is the regular integer function, looks like this. The one they just asked us to do, if we go down here, was 4, math, arrow to the right, choice 5, x, and then they had a plus 1 on the back. I don't think moving it up 1 is going to do a whole lot. The moving it up 1 meant instead of this little blue piece right here from 0 to 1, it's up 1 here. But the 4 meant it skipped from 1, then it's all the way up at 1, 2, 3, 4, 5. It's a distance of 4 between one step and the next. Interesting, okay. Then we have a vertical compression by a factor of 1/3. Again, going back to the very first function. So that would be this guy. And left 6 units would be opposite because it's inside, so it would be plus 6. That's my take on that one. So let's try that. I think the 1/3 is going to put them real close together. Again, you don't have to be doing these on the calculator. You just have to write the equation. I'm just doing them because I like to show you what it would look like. Math, arrow to the right, integer, which is choice 5. And then we had x plus 6. I did put my parenthesis in, or my fraction in parentheses out front. All right, let's look what that does. Oh, it does make them very close together. They almost look like they're touching. And then it had an x-intercept over here instead of at 0. Moved 6 to the left. All right. This one, parent function, anybody recognize that one? That is a cubed root. Okay, should be on your reference sheet or check your notes. Reflected over the y-axis. That means it's shifted this way. This is one that it wouldn't matter if which axis we reflected it over, it's going to be the same difference because it has origin symmetry already. So the reflection in the y-axis actually means inside, but it wouldn't matter for the graph purposes if we put it on the outside. Then translate 4 units to the right. Oh. 4 units to the right is a -4. I'm a little concerned whether we need parentheses here. I don't think we do. So I think we're good. We want it to show up 1, 2, 3, 4. We want it to show up over here. So let's try it. Y, we're doing the cubed root, which is also under math. If you want to use the cubed root button, it is choice 4. I would normally just do to the 1/3 power because I'm too lazy to use that cubed root button, but since we're just learning that, I will go math, arrow to the right. Whoops, nope, just kidding, don't need arrow to the right. Negative x minus 4. So the question is, did it shift left 4 and the opposite shape? Yep, I think we're golden. All right, and then the last one says horizontally compress by 1/2 and translate down 5. Ooh. Horizontally compress by 1/2. Horizontally is inside, and inside is the opposite of what it seems. So instead of putting a 1/2 inside, I'm going to put a 2 inside. And so I have the cubed root of 2x would horizontally compress it by 1/2. And then down 5 is on the back. So I'm thinking that that should be smushed in a little bit. And from the original one, should be down 5. 1, 2, 3, 4, 5. So down here, but instead of going up 1 and over 1, it's going to go up a little faster like that and be smushed in. Is what I'm thinking. Let's see what happens. Math, cubed root. Oh, what did I push? 2x, and then a -5 on the back. Okay, it's a little hard to tell, but do you see how it's smushed in? It's got a little more straight up and down right there than the blue one did. All right, I'm gonna go through a couple tricky ones here. This says this right here is reflected across the y-axis. That means you would take the opposite of x in here. And then I'm actually going to leave a parenthesis in there. All right, there's a negative there and then an x. I didn't write that well at all. I'm going to erase it anyway because now we are supposed to go 6 units to the right. It's already 5 units to the right, so if we go 6 more units to the right, we're going to end up with an x minus 11 in there. And it actually wouldn't matter if you put the negative inside or outside of that. Multiply it by 2. And then it says, and down 2. So it used to be up 3. If we go down 2 from there, it'll be a +1. All right. Yeah, those are tricky. I'll be honest, and I'm not going to put that on a test or quiz. Function was vertically stretched up by a factor of 2. And we're supposed to undo it. We're supposed to find the original. So if this got multiplied by 2, it used to be a 3. All right, it was translated 2 to the left. Well, right now it's 4 to the left. So if we took off 2 of those, it would only be 2 to the left. And then 5 units up, well, it's down 1. It used to be down 5 more, so it was down 6. So there's the original. Let's talk this through, because now if I stretched it by 2, and then 2 left, would be adding 2 more, and then 5 up would be adding 5 back here. Would that give us what we had originally? I think so. So I think this is the original. Those are tricky, very tricky. All right, but that's what this is, and I did assign a few of these. It's not quite this complicated, but it says what transformations are occurring from here to here. See, this only has one thing that changed. It was up 7 and now it's down 4. So to go from up 7 all the way down to -4, it slid down 11. This one, the 1/3 stayed the same, but in here it went -6, which would be left 6. Nope, just kidding. Right 6, opposite of what it seems. And then on the back, it used to be up 6, and now it's only up 3. So it actually shifted down 3 to get here. From here to here made it go down 3 because they subtracted 3 off. All right, I'll come back and do number 3. You can try it on your own first and then check the answers on the notes. All right, this one was up 3 and now it's down 2. So they took a 5 off of there. 3 minus 5 would be -2. So they shifted it down 5 because that was an up down on the back. I'll do number 5 in the notes, but you can try it. Number 6, this negative did not change, so we don't have to talk about that. This was right 3 and now it's right 8. So how much further did it go to the right? Was 5, and then it was up 2, but now it's down 6. So it had to have shifted down a total of 8. Because if you told me to go back here and shift this down 8, then you'd end up with a -6 back here. And in here, if you told me to shift it right 5, that would be minus, and I would end up with a -8. All right, so you do have a couple of those on the homework. I'm going to review real quick, putting the transformations in. This one says to shift it down 2 first, then reflect it over the x-axis, which actually is this. You have to do parentheses because it said to shift it down. So it's down here, and then reflect it over the x-axis, which would put it up here. You could distribute that negative, but we'll just leave it. And then a vertical shrink of 1/6 goes in here. So the final answer is -1/6 x squared minus 2, like that, okay? I think that's harder than anything I put on a quiz too. All right, right 6, horizontal stretch of 2. Right 6 is inside, but it's opposite. Horizontal stretch, oh my gosh. Horizontal stretch is inside. So we have a horizontal stretch inside, and a stretch inside is the opposite of what it seems, so it actually divides by 2 instead of multiplying by 2. Wow, these are tricky. All right, vertical shrink of 1/2, that's just out front. Shift the whole thing up 3 is +3. Reflect over the y is change the sign inside here, which actually won't matter. You could put it out front. Yeah, I think that's good. We're not going to worry about it. I won't give you one like that. All right, horizontal shrink of 1/2 is inside, and anything inside is the opposite. And then we shift it up 3, and reflect it over the x-axis comes on the outside. And because it's the last thing, we need parentheses there. If it said to do it first or after the horizontal shrink, we could put it on here. But because we shifted this whole thing up 3 and then we reflected it, it's got to be down here, which is like an upside down. If you distributed this, we'd have a negative, which is why it's like it's upside down and then shifted down 3. Okay, that was a tricky one too. All right. Last little bit. These are tricky as well. I'm just trying to get all the hard stuff out of the way so that the easy ones on the homework will seem easy. We need to figure out what 2 things happened to make this one into this one. So it had an x-intercept at -3, 0, and 1. And then it went up here as high as 1, 2, -2, 1, 2, 3, 4, 5, 6, roughly -2, 6. Okay. Now it is over here at 2, 6, or 7, 2, 7, 2, 7. Interesting. So it changed the x, sign changed. This flipped across the x-axis. So it reflected, I'm sorry, the x's changed sign, so it reflected over the y-axis, which is an inside. So if we call this f of x, we have a negative inside. And then the other thing that it did is it used to go to 7 and now it's up 1. And this used to cross here at -3. And it's here and here and here. So after it flip-flopped across the y, it also shifted up 1, which is why this ended up here. Up 1 would be a +1. All right, so that was tricky. And this one's even scarier to me. We are supposed to find 3 transformations. Well, the first thing I noticed is that it is vertically stretched up and down. Okay. Actually, it had an x-intercept at -3, 0, and 1. And now they are at 0, 1, and -4. Interesting. But I don't think that matters because I think it's stretched anyway. Let's go top to bottom. This went from -1 up 1, 2, 3, 4, 5, 6. So it was a total of 7 units up and down. And now it is from the top here almost up to a 2 and down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is like down 12. And up 2. So that's a total of 14. So I would say it's stretched vertically by a factor of 2. Whoops. With a parenthesis. But it is also reflected, I would say the y's changed up and down. Okay, it's reflected up and down because this y value of up 6, it was -2.6, is shifted down here. And then I think it's shifted 1 to the left after they flipped it upside down. Okay, let's start these in order here. If we stretched it by 2, it would have gone up twice as high and down twice as low, which isn't much. Okay, and then when we flipped it upside down, let's try a Hofbauer magic here. Oh, that's not going to work. Just kidding. I thought I could take this. It's 2 pieces. Okay, just kidding. And we need to flip it upside down, so I'm going to do that in a new color. It now would go down here and up here to 2. Okay. And it would go all the way down to like -12. Remember, they changed the scale over here. They changed the vertices up here. And then they shifted it over. Just, I think, 1 unit to the left, which would be in here a +1. So I'm getting -2 f of x plus 1. All right, that was messy and hard. So you have much easier questions to do on your homework. And I'm skipping that one because it's 3 transformations again and icky. Just a couple more slides. You don't have these, but you got to get good at that matching thing again. And I want to talk through these. This original one up at the top had zeros at 1 and 4. This one has zeros at 1/2 and 2. That means the x's changed. When the x's changed, it's got to be inside. So it's one of these two. And they are half as much, but remember, it's the opposite of what it seems. So it's actually multiplying by 2 inside that would make the x's half as much. The y's all stayed the same as the parent function up at the top. I hope you're still watching because this is a really good example. All right, this one down here, from the parent to here, let's see, it was going from 1 to 4, so 3 units across. 1, 2, 3, 4, 5, 6 units across. So I'm thinking this stretched horizontally because the y's didn't change, only the x's changed. The x's doubled. Well, unfortunately, what it happens to an x, it's the opposite of when it seems. So inside here, 1/2 of an x is what happened. So that's B. All right, down here, for these two, let me see, is that, of course not. Let me take a little picture of the parent. And scroll down the page here. And this is the parent, okay? So the parent function here to this one, the x's all stayed the same. So the y's changed and they doubled. So that goes on the whole function because remember f of x means y. And outside it's what it seems, the y's doubled, it's stretched vertically. And on this one, from here to here, this went down 2 and now it's only going down 1. This is a vertical shrink. So that's a 1/2 out in front, or the whole function over 2. Okay, that was a great example. Should have put that in the slides earlier. I feel like there's one more here. Oh, this one just talks about the reflecting. When you reflect and the x's change, so you reflect across the y over to here. So that flipped this way. The x's changed. Okay. That would be this guy. So that's choice B over here. And when you flip it up and down, the y's change, the x's don't, so it stays here, but the y is going to go down here. And is that the right shape? I think it flips upside down. So, this guy was going the wrong way on mine. But it is upside down this way. The y's changed sign. And so that was this guy with the negative outside. All right. And this one just takes you through. First, this one would move it left 3. The 2 here would double all the y values. And the last thing it does is it flips over the x because of the negative outside. All right, so I hope some of you stayed watching. These two were particularly helpful, but again, we have almost a 42-minute video. The Monday of this week is killer. Thanks.